Hi, I wanted to talk to you about how old a rock is, or how do we figure out the age of a rock. When we're looking at sedimentary rocks and figuring out the age of a rock, it really depends on what type it is. So here we've got a whole bunch of sedimentary rock layers, and sedimentary rock is created by sediment laying down on the Earth's surface. It gets pressed and hardens into rock, and then maybe another layer goes on top of it, another layer, and another layer. And we know that if these are older, if these are horizontal, that this one is probably the oldest, and this one is probably the newest, if they're sedimentary. And that is called the law of superposition. That works for horizontal layers of sedimentary rock. Now, this gives us the relative age. So what we're doing is we're relating one layer to another. We know that this one is oldest, this one is newest. We don't know the exact age or absolute, but we know in general which one was here first. Also on this drawing, there's a fault. And if you remember from 6th grade earth science, a fault is a crack in the Earth's surface. So in this case, we can also look at the relative age of this fault. And in this case, if you take a look at it, the layers were clearly here before the fault shifted them. So the fault happened last, which means it's newer. And that's how we figure out the relative age of sedimentary rocks. And when you have horizontal layers, the one that was closest to the bottom is the oldest, the one at the top is the newest. That's called the law of superposition. Here what we have is an igneous intrusion into the same set of rocks or the same set of sedimentary layers. And remember that down in the earth you have a whole bunch of molten material, and if it's down there, it's called magma. So this igneous intrusion, it intruded, so basically it moved up this way, it intruded into the existing rock. So because it basically formed this space in this rock here, it has to be relatively younger than the other rock. So even though it's down here by this old layer, remember the law of superposition says that in horizontal layers of sedimentary rock, the further down it is in the layers, the older it is. Up here it's newer. Even though this igneous is down here, that doesn't apply because remember the law of superposition is just for sedimentary layers. This is igneous. Now if the igneous rock kept moving, or that magma kept moving, and it basically spilled out onto the surface, once it breaks through, it's no longer called magma, it's called lava. And that's not called an intrusion. It's not in the earth. It's an extrusion. And that forms a different kind of igneous rock. The other thing we should probably discuss here is this fault. Now if the igneous intrusion, or extrusion for that matter, is unaffected by the fault, then it's a little tricky to find out which one is older or newer relatively. If that intrusion came over this way and all of a sudden it was shifted down, if the fault moved it, then we know, hey, the fault happened after this was here. So the fault's newer, this is older. But if the intrusion just keeps going as normal, and we can see that, oh, that igneous rock just flowed straight into this and the fault didn't move it, then we know the fault happened first, it's older, the igneous intrusion is newer.